This is video 7 for simplifying expressions. We are now going to work on factoring using the greatest common factor. So in order to find out what that greatest common factor is, we need to break down our expressions. So we are going to factor 2x. Well, 2 is actually prime, so it's really just 1 times 2. We're not going to break that down. So the prime factorization of 2x is just 2 times x. 6, however, we can factor as 2 times 3. So we can write this as a positive 2 times 3. So this expression that I've written here, 2 times x plus 2 times 3, is the same as 2x plus 6. Our goal is to identify what they have in common. In this case, they both have a 2. So 2 is actually the greatest common factor. The GCF in this example equals 2. So I'm going to do the opposite of distributive property and take that 2 out and write what we have remaining. What's left in the first term is just an x. What's left in the second term is just a 3, and they are both positive. So notice what I have here. This is our factored form. If I were to multiply 2 back in, 2 times x is 2x, and 2 times 3 is 6. You see how this matches? Your goal is to factor it and write it as a product of 2 separate expressions. So let's do the same thing for the next example. 3 is actually prime, so the first term we are not going to factor, it's just 3 times x. But the second term, 18, does have some factors. Think of any two numbers that multiply to make 18. I know 2 times 9 is 18. 2 is prime, so I'm done factoring 2. 9, however, is not. I'm going to continue factoring 9. I get 3 times 3. Each of these numbers are prime. Their only factors are 1 and 3. So now I can write out the prime factorization of each term. The first is 3 times x. The second is 2 times 3 times 3. There's a negative in the middle. That means we are subtracting these two expressions. So what I have written here, 3x minus 2 times 3 times 3 is the same as 3x minus 18. So what do they have in common? Well, they each have a 3 in common. So the GCF in this example is equal to 3. So that's what I'm going to take out of each term and put out in front of our parentheses, and I'll write down what's remaining. In the first term, we have an x remaining. In the second term, we have a 2 and a 3. So 2 times 3 multiply. I'm not going to circle so we don't get confused, but I'm multiplying 2 times 3, which gives us 6. And then it is a negative. So if I were to distribute 3 back in, 3 times x and 3 times negative 6 would give me 3x minus 18. So if this example is complete, we have our GCF equals 3, and we have our product, which is 3 and x minus 6. Next, let's factor 6x minus 15. 6 is not prime, so we have 2 times 3, which is 6. Each of those numbers are prime. So this is 2 times 3 times x. That would be equivalent to 6x. 15 can be factored between 3 and 5. Both of these are prime. 3 and 5 don't have any factors other than 1. So I'm going to write minus, because that's what's in between these, 3 times 5. What do they have in common? A single 3 in common. So the GCF is equal to 3. That's what I'm going to factor out of each of these expressions. And what's remaining is a 2 times x, so it's 2x, and a 5. And since it's negative, it's going to be minus. Oop. Change the color. Just stick with the pattern. 3 times 2x minus 5. Next example. Let's factor 8. Two numbers that multiply to make 8 are 2 and 4. 2 is prime, however 4 is not. Let's continue factoring 4, which is 2 times 2. So the prime factorization of this 8x is 2 times 2 times 2 times x. And then we can factor 12. 12, I know, is the same as 3 times 4. 3 is prime, 4 is not, so I get 2 times 2. Now, if you say, hey, what about 2 times 6? Well, 2 and 6 work. 2 is prime, and then if you continue factoring 6, which is 2 times 3, you're going to get the same prime factorization, a pair of 2's and a single 3. So this is plus 12, so it's plus 2 times 2 times 3. So what do they have in common? In this example, not only do they have a 2 in common, but they have a pair of 2's in common. So I'm going to factor out a 2 times 2. 2 times 2 is 4, so that is the GCF. In this example, the GCF equals 4. What's remaining? A 2 times x. And in the second term, a single 3. So if I were to distribute 4 back into this problem, 4 times 2x would give me 8x, and 4 times 3 would give me 12. So the GCF is 4, and my product is 4 times 2x plus 3. Next, we have a 15x squared. So let's factor our 15. That is the same as 3 times 5, where both are prime. And since this is x squared, I'm going to separate those x's as well. This is 3 times 5 times x times x. We can factor the 20x. This is the same as, say, 2 times 10. And then 10 is the same as 2 times 5. So 2 is prime, and so is 5. Since they're being added, I'm going to write plus 2 times 2 times 5. And don't forget, this term also had an x. So the GCF doesn't always have to be a number. Yes, they have a 5 in common, but they also have a variable in common. So I'm going to take out a 5 times x from each of these. That means the GCF in this example is equal to 5x. What's remaining in the first term is a 3 and an x, so that's 3x. And in the second term, I have a 2 times 2 remaining, which is 4. And it's positive. So this is my factored form. If I were to redistribute 5x times 3x, I'd get 15x squared. And 5x times 4 would give me 20x. Next, we are factoring a 21, which is 3 times 7, and both of those are prime. But notice we have an x and a y, so I'm going to just write those separate, 3 times 7 times x times y. And then the next one, we have a 14, which factors between a 2 and a 7, where both of those are prime. Don't forget it's minus. So it's minus 2 times 7, and this term also has an x. So the common factors are 7 and x. So we write the GCF is equal to 7 times x. So I'm going to factor out a 7x from each of these terms. That's what I put in front of my set of parentheses. What's remaining in the first term is a 3 times y. In the second term, I just have a 2, and it's a negative. So I have 7x times a 3y minus 2. If I did 7x times 3y, I get 21, and x times y is just xy. And 7x times negative 2 would also give me a negative 14x. So go ahead and practice these problems on your own, and then check the answers in the next video.